This is a video from the Chapter 6 review, and we're going to take a look at problem 11. The base of a solid is the region bounded by y equals x squared and y equals 2 minus x squared. Find the volume of the solid if the cross-sections perpendicular to the x-axis are squares, with one side lying along the base. Now, remember that the general formula for volume is the integral from a to b, and it's the area of the cross-section integrated with respect to x. Okay? Now, let's draw a picture. So, here's the y-axis, and here's the x-axis. So, y equals x squared is a parabola that looks something like this. Okay? And then y equals 2 minus x squared is a parabola that goes something like this. And so again, we just need a rough sketch. Doesn't have to be perfect, right? And now we need limits. So we need a couple things. We need limits. And so what I'm going to do is I'm going to set x squared equal to 2 minus x squared. So that says x squared has to equal 1. And when I solve for x, I get plus or minus 1. Okay? So now I can figure out my points of intersection right here. Now, I'm going to draw a blue line that connects the parabola y equals 2 minus x squared to the parabola y equals x squared. And notice how that blue line is perpendicular to the x-axis. So now remember, we have a square. And one side of that square corresponds to that blue line. So the question I have is, what's the length of that blue line? And the length of that blue line is going to be 2 minus x squared minus x squared. So basically it's the top function subtracting, or I'm going to take the top function and minus the bottom function. Okay? So a of x is going to equal, I'm going to take the side 2 minus 2x squared, and I'm going to square it. That's how we get the area of the square. We take the side and square it. If I square that out, I get 4 minus 8x squared plus 4x raised to the 4th power. Now I'm ready to find my volume. So the volume is the integral from -1 to 1 of, now let's remind ourselves, it's going to be 4 minus 8x squared plus 4x to the 4th power. And I'm integrating with respect to x. So this is 4x minus 8 over 3 x cubed plus 4 over 5 x to the 5th, and I'm evaluating from -1 to 1. If I plug 1 in for x, I get 4 minus 8 over 3 plus 4 over 5. If I plug -1 in for x, I get -4 plus 8 over 3 minus 4 over 5. Just like this. Now, let's go forward. I'm going to take 4 minus a -4, and I'm going to get 8. I'm going to take -8 thirds right here, and I'm going to subtract off 8 thirds to get minus 16 thirds. And then I'm going to take 4 fifths and subtract off -4 fifths to get 8 fifths. 8 fifths. Sorry. So the LCD here is 15. And so I'm going to write this as 120 over 15 minus 80 over 15 plus 24 over 15. So the correct answer here should be 64 fifteenths. And that's how we do number 11. I want to take a look at the average value problem. So this is number 14, and it says, find the average value of f of x equals x secant squared x on the interval pi over 6 to pi over 4. So I like things that involve trig. Now, let's take a look. Pi over 4 minus pi over 6. This is equal to 3 pi divided by 12 minus 2 pi divided by 12. And so that's equal to pi over 12, right? And so if I want the average value, which I'll call f sub av, right? So this is 1 over pi over 12. And then I'm going to take the integral of. Now, the lower limit is pi over 6. The upper limit is pi over 4. And then I'm going to integrate x secant squared x dx. So this is 12 over pi times the integral from pi over 6 to pi over 4 of x secant squared of x dx. Now, this is a classic integration by parts problem. I'm going to let u equal x, and I'm going to let dv be secant squared x dx. So du is 1 dx, and v is tangent x, like so. So f sub av, right, the average value, is 12 over pi times the quantity. So I'm going to take x tangent x, and I'm going to evaluate it from pi over 6 to pi over 4. So the notation should look something like this, okay? And I'm going to go minus, and then I'm going to integrate from pi over 6 to pi over 4 of. Now here, it's v du, which will be, let's go back, which will be tangent x dx, just like this. So this is 12 over pi, and then I'm going to multiply that by pi over 4 tangent of pi over 4 minus pi over 6 tangent of pi over 6 minus, and then in parentheses, I'm going to have natural log of the absolute value of secant x, right? And then I'm going to evaluate from pi over 6 up to pi over 4. And I'm going to close this off here. Now, this is 12 over pi times. Tangent of pi over 4 is 1, right? So I'm going to get pi over 4. And then tangent of pi over 6 is going to be 1/2 over the square root of 3 over 2, which is going to be 1 over square root of 3, like so. Then I'm going to go minus. Now, in parentheses, I'm going to take natural log of secant of pi over 4, And I don't need absolute values because I know secant of pi over 4 is non-negative, greater than 0. So I have natural log of secant of pi over 4 minus natural log of secant of pi over 6, like so. I hope that's readable, okay? Now, this is 12 over pi times. I'm going to get pi over 4 minus pi over 6 times the square root of 3 minus natural log of, now, secant of pi over 4 is square root of 2. So I'm just going to put square root of 2 here, okay? Then I'm going to go plus, and then, and again, that's because a negative times a negative is a positive, right? And then I'm going to go natural log of, now let's reason this out. If I want secant of pi over 6, I just happen to know that cosine of pi over 6 is square root of 3 over 2. So I'm going to go 2 over the square root of 3, like this. Now, we could push this a little tiny bit, right? So this is 12 over pi times. We're going to get pi over 4 minus pi over 6 times the square root of 3. Okay. Then I'm going to go minus 1/2 natural log of 2 plus, and then I'm going to go natural log of 2 minus natural log of square root of 3. And I'm going to go just a little bit further, okay? Now, if I distribute, I'm going to get 12 over pi times pi over 4 minus 12 over pi times pi over 6 times the square root of 3 minus 6 over pi natural log of 2 plus 12 over pi natural log of 2, okay? I hope that, so I just distributed to every term, right? Minus 12 over pi times 1/2 natural log of 3, because that's what this piece is equal to, 1/2 natural log of 3. Now, I'm going to push this a little bit. So I'm going to get 3 minus, pi's cancel, right? And then I'm going to get 2 over square root of 3 plus, if I combine these two, I get 6 over pi natural log of 2, right? Minus 6 over pi, right? Because 2 goes into 12 6 times. So I get 6 over pi natural log of 3. And you get to hear I'm pretty happy. And that'll do it for this video on the exam chapter 6 review. And we looked at problems 11 and 14. Thank you.